Alright, so let's solve another couple problems. And if you've looked at the previous videos, you'll recognize that it's kind of repeat. The idea, the pattern is being established. These problems are very similar in their solution. Alright, so let's take a look at this. In equation 1, we have all three variables. In equation 2, we have all three variables. And in equation 3, we only have two of them. So what I'm going to do is take equation 3 and substitute it into equation 1 and then into equation 2. So let's sub equation 3 into equation 1. So if we do that, then we'll no longer have x's. We'll just have y and z. So let's go 5, and instead of writing an x, we replace x with what we know it to be, and in terms of y, x is the same thing as 3y plus 1. Now we've got minus 4y minus 3z is equal to 3. So now what we want to do is combine like terms, and any numbers that do not have that are not a coefficient of a variable, a number by itself, get it over here on the right hand side to combine it with that 3. So let's distribute this 5 to both terms. Everything inside the parentheses gets multiplied by 5. So we have 15y plus 5 minus 4y minus 3z is equal to 3. Well, we've got like terms here with the y variables. 15y's take away 4y's will leave us with 11y's. Then I've got this minus 3z. This 5, I'm going to subtract 5, so it'll cancel. And if I do that to balance the equation, I have to subtract 5 from the right-hand side. Alright, so if I call this equation 4, I need to give myself a little bit of room. So now let's come back and take this equation 3 and substitute it into equation 2. So equation 2 has that z is equal to y plus x, but I know x to be 3y plus 1. So instead of writing x, I replace it with 3y plus 1. So let's combine this. It's often helpful to put a coefficient of 1 in front of there, just to make sure that you add it to the other like terms. Now, if I compare this equation to equation 4, it's a little bit different. In equation 4, the variables, the letters, are on the left-hand side, and the number by itself is on the right-hand side. So this 4y, if I subtract it from the right-hand side, I'll have to subtract it from the left-hand side. And since this y is written first, I'm going to write the negative 4y because I can't combine the y and the z because they're unlike terms. So I've got negative 4y plus z, and this positive 4y and negative 4y cancel each other out, and I have that equal to 1. So I'm going to call this equation 5. So now, if we look at equation 4 and equation 5, it's to our advantage to look for a coefficient of 1, or to look and see if they have coefficients that are equal and opposite. Since this is a negative 3, I would love for this to be a positive 3, because then I could eliminate the z variable by adding these two equations together. But as it is right now, if I add them together, nothing will be eliminated. So in order to eliminate it, my Christmas wish is that this 1z was a positive 3z. So I'm going to multiply both sides of this equation by the number 3. So let's look and see what that does for us. When every term in this equation gets multiplied by 3, we have negative 12y plus 3z is equal to 3. And if I now take equation 4 and my new equation here, equation 6, and if I add them together, the z's will be canceled. So I'm going to do that. You can write them right underneath each other. For me, I'm just going to move them right underneath each other here. All right. So here's the reason that I wrote the y and here instead of writing z minus 4y, I wrote negative 4y plus z, so that the columns would be lined up and just easier for me to add these together. I've got negative 12y plus 11y is a negative 1y. The positive 3z and negative 3z cancel. That just gives me a 0, and I don't have to write 0 there. And 3 minus 2, or negative 2 plus 3 is just 1. So if I divide or multiply each side by a negative 1, then I have y. I have that y is equal to negative 1. Now remember, I didn't write this up here, that we're trying to figure out what x, y, and z equal, and we have just figured out that the y variable is equal to negative 1. So I can come back now to equation 4 or equation 6, plug in y equals negative 1, and solve it for z. I could actually do it before I even multiplied by 3, but let's just do it on the immediate equations. So I'm going to shrink this up again. So it doesn't matter which one I pick, so I'm going to pick equation 4. And instead of writing y, I know that y is negative 1. So that said 11 times y. So 11 times negative 1 minus 3z is equal to negative 2. I have one equation and one unknown, and I can solve for z. So let's step by step try to get z by itself. Z is contained in the second term. Let's get rid of this first term by adding 11 to each side. When I do that, the negative 11 and positive 11 cancel each other, and I have just the negative 3z on the left, and negative 2 plus 11 is 9. If I divide both sides by negative 3, the negative 3 divided by negative 3 is positive 1, and I just have 1z. And positive 9 divided by negative 3 is a negative 3. So now I have my second answer here. And to figure out what x is, I can use any one of these. All of these equations have x. I'm going to go ahead and use equation 3 because it already tells me that x equals. It tells me that x is equal to 3 times y plus 1. But I know what y is. Why do I have to write y there when I know y to be negative 1? So I've got that x is negative 3 plus 1, which is negative 2. Alright, so if I look here at equation 3, is it true if I replace x with negative 2, is it true that 3 times y, 3 times negative 1 plus 1, is that negative 2? Well, sure it is, because negative 3 plus 1 is negative 2. So, hey, that checks. What about the second equation? Z was negative 3, and the big question is if you add y and x together, if you add y, which is negative 1, and x, which is negative 2, yeah, negative 1 plus a negative 2 is negative 3. And let's check this final equation. If we take 5 times x, where x is negative 2, and we subtract 4 times y, where y is negative 1, and subtract 3 times z, where z is negative 3, if we do this arithmetic, the question is, do we get positive 3? Well, let's see if we do. We've got negative 10 plus 4 plus 9, negative 10 plus 13, and negative 10 plus 13 is 3, and so that checks. So I'm pretty happy with that then, and I'm pretty sure that this is my correct answer. Let's do another one. Let's see, we've got 3 equations and 3 unknowns. We want to solve for x, y, and z. They've already told us immediately that z is negative 2. So let's take equation 3. Let's sub equation 3 into equation 2. And everywhere we see a z, we can replace it with this known value of negative 2. So I've got 3y plus 2z, but I'm not going to write the letter z because I know that that variable z represents a negative 2. So I've got 3y minus 4 is equal to negative 1. To get this y by itself, this term that doesn't have the variable, we'll move it to the other side, and we'll divide each side by 3. We recognize that 3 times 1 is 3, so we know that we're getting 1 for y. The only equation that has the variable x is this equation number 1, so let's copy it down, but we replace y and z with these known values of positive 1 and negative 2. So if I copy down equation 1, I have x plus 2, and not 2 times y, but 2 times 1, because I know that y is equal to 1. And then I've got plus 3z, but I don't write down z. I know that z is the same thing as negative 2. And I know that if I do this arithmetic, then I'll get a negative 1. So two minus 6 is a negative 4. To get this x by itself, let's add 4 to each side. And if we add 4, the negative 4 and positive 4 cancel. And adding 4 to the right-hand side, I get 3. Alright, z is self-checking because it's just saying that z is negative 2. Let's take a look at the second equation. 3 times y, where y is 1, plus 2 times z, where z is negative 2. If we add these together, we get negative 1. 3 minus 4 is negative 1, so that checks. If I replace x with 3, and y with 1, and z with negative 2, and if I do this arithmetic, the question is, do I get negative 1? Well, I've got 3 plus 2 minus 6. I have 5 minus 6. Hey, that's negative 1, and that checks. So I'm pretty confident that this is the correct answer. So hey, I hope that helps, and I'll talk to you later.